So now we're talking about anterior column, and it's going to be predominantly motor tracts. So obviously those are going to be descending tracts. And then how many neurons are they going to have? Two. And where's the synapse going to be? No thalamus. Motor is descending. It's usually going to synapse in the gray matter of the spinal cord. Is it going to be dorsal horn or ventral horn? Ventral. Right.
Ventral, you said?
Yeah. Because in the gray matter of the spinal cord, it's mostly going to be the front of the gray matter, and sensory is usually going to be the back. All right, so there is going to be an anterior column. Like I said, most of them are going to be descending, but we are going to have a ventral spinal thalamic tract. But that's what we already talked about. So primarily we're talking about descending tracts. And it's going to be ventral cortical spinal tract. And that's going to be for motor. Here's where we get into what's called the pyramidal system. The pyramidal system and extrapyramidal system, although I think those are older terms and they're not necessarily used as much anymore. So we've got ventral and lateral cortical spinal tract. So the motor fibers are going to begin in the motor cortex. So most of the fibers are going to cross over at what we call the pyramidal decussation, which is basically going to be at this point right here. Okay, so if you remember, here's the pons right here. So it's going to cross basically right here. Okay, so here's the medulla oblongata looking at the front side of it. It's going to cross right there, and that's what's called the pyramidal decussation. So they're coming across here, and most of the fibers are going to cross right there and descend in the anterior part of the white matter in the spinal cord. And then a lot of times you'll see this different diagram here where it has to do here in the precentral gyrus. So different parts of the body. Obviously there's going to be more fine motor control to things like the face. And so that's why there's a larger part of this cerebral cortex controls that. And then also again with the hand, because you have a lot more fine motor control here. And then other things like in the feet or some of the other parts of the body, there's not as much fine motor control. So they're going to come down, they're going to cross just below the medulla, and then descend. And then that's going to be the lateral cortical spinal. So the ones that cross are the lateral cortical spinal. And then this other 10% that don't cross is going to be the ventral cortical spinal. And so then they're going to cross at the level of the spinal cord where those nerve roots exit. And so when you have lesions in the spinal cord, you're mostly talking about the lateral tract because that carries 90% of the fibers. So that's the main thing that's significant. So again, it's like the body's trying to have a redundant wave so that if there's a lesion to half of the spinal cord, you're not going to lose all of your motor fibers. You're going to lose most of them because they're mostly in the lateral spinal thalamic, but you're still going to have a little bit on the other side. So then now if we're talking about, okay, so then when we say lateral spinal thalamic, that's this one that crossed here, it's the pyramidal decussation. And then you have the ventral corticospinal that don't cross until you get to the level of the spinal cord.
This says they never cross over.
They do actually, they do later on at the level of the spinal cord. Yes, eventually they do cross. It's just that some of them are going down one side and some are going down the other, and eventually the lower one, the ventral, is going to cross later down at the level. So they do cross the body. Just not, one crosses in the beginning, the other one crosses right at the end. And so what we're saying, like I said, is that most of the time when you have lesions in the spinal cord, it's affecting the lateral corticospinal because that's where most of the fibers are. So again, when you understand that the cerebral cortex is going to be motor to the opposite side of the body. Okay? It's just like when we were talking about strokes. That if you have a problem in the brain on one side, it's going to affect the motor on the other side of the body. But if you're talking about the level at the spinal cord, it's going to be the same side. Okay? Because most of the fibers have already crossed up here. So if you're talking about half of the spinal cord, it's going to affect motor on the same side in the spinal cord, but opposite side for the brain. So then, right side of the brain, what motor part of the body is going to affect?
Left.
Okay, so left side C3, arm or leg or both?
Both.
Again, anything that gets up above C4, C5, you're talking about the arm and the leg. So T12, is that going to affect the arm? No, but it's going to be the same side motor. Okay, so here again, now we're getting into dermatomes. And then again, I mean, I realize you can't necessarily see all the numbers on this chart, but the picture is just more for general purposes. There's a lot of different dermatomal charts that you're going to go over, and we'll go over that more when we get into the brachial plexus next time. So basically, it has to do with embryological development. You know, as the body's being formed, the nerves are growing out, and then just think of it like this. You have, C1's going to go C2, then you start getting C3, C4, up here C5, then C6, 7, 8, T1, T2. Because it's like the arm and leg grow out of buds. They'll start up short like this, and then they would grow out like that. So if you think of it in terms of not exactly anatomical position, but more like this. Okay? So it's just the different nerve root levels as they come out. And then, there's a little bit of overlap. It's not like an exact demarcation. So let's say if you get, T2 or T3, if one nerve root's affected, there's going to be some overlap. So you're probably not going to lose much sensory stuff. But with dermatomes, they're going to be more significant, like we're talking about nerve root herniations. Disc herniations affecting nerve roots. So patterns of radiating pain. So basically, dermatomes are just areas sensorily on the skin that correspond to certain nerve root levels. Because you have what's called dermatomes, and then what's a myotome going to be?
What?
Myotome.
Muscle.
Yeah, so it would be muscles. So we'll talk about specific levels. Myotomes are certain muscular movements that correspond to a certain nerve root level.